Okay, so yes, the recording has started. Okay, so what I'll be doing is, like, as soon as we finish with the session, there is a recording file which will be created. So I'll convert it to a video format, and I'll either upload it on YouTube as a private video which you can access, or maybe I can share it with you on Dropbox or something like that, so that you have access to the file.
Sure.
So which one do you prefer? I mean, me putting it on YouTube for you to view, or do you want it on Dropbox?
Well, YouTube should be fine. That should be fine, I think.
Okay. Yeah, and I'll keep the video private because I do not want to share the conversation and all that what we have, so it should be okay.
Of course.
Okay. Okay then. So yeah, what I did was, in the meanwhile, I also put up my own setup in the sense, what I did was I have a virtual machine that I have running here. Okay. Yeah, there you go. It's a Windows 7 machine that I have. And apart from that, I also have a 2008 server, which I set up as a CA server.
Right on.
Okay, so both the options are available in the sense, like, you may have your setup with you.
Yes.
We can also look up into that. But like, as far as our demos or whatever we need to do, even I have a setup running.
Yep.
Okay, but my only concern with regards to this setup is, like, sometimes, my memory utilization or my hard disk utilization shoots up to around 95–99%. So that's when everything starts, like, I mean, going berserk, I would say.
Sure.
My laptop freezes up. Yeah. So at this point, it seems to be doing good. But at any point of time, if it freezes like that, I think I'll switch off everything and start off everything. That is what I'll think about. Okay.
I understand.
Yeah. Okay. Okay. So yeah, let me get back to that. Okay. So let's start off with it.
Sure.
Okay. So when it comes to basic site-to-site IPsec VPN, like I said, we'll just have a quick overview of the site-to-site VPN first of all. Yeah. So when it comes to configuration choices or, configuration procedure and stuff like that, I mean, primarily, the main thing associated with site-to-site VPN is the two peers which are involved in that site-to-site VPN should have direct reachability with each other.
Right.
Okay. Now, of course, I mean, across the internet, it's not a direct connection between them. But overall, what we're looking at is from this Cisco ASA firewall that you see at the left-hand side, it should have direct reachability or some sort of connectivity directly to the public IP on the ASA firewall on the right-hand side. Okay. Because the reason is these are the two peers which are going to exchange some authentication credentials in the form of either a pre-shared key or it could be digital certificates. So they need to authenticate to each other first. And then these are the two peers who are going to establish a secure channel between them, a channel through which it's going to pass the regular IP traffic, the routed traffic. Okay. Okay. So when it comes to that, like, as you can see here, the very first component as far as the IPsec VPN negotiation goes, the first protocol is the ISAKMP, that is Internet Security Association and Key Management Protocol. Okay, so it is this particular protocol which handles the authentication of the two peers. Like in this slide, as you can see, they are getting authenticated using pre-shared key. But ultimately, that's the authentication credential that they are utilizing or they are showing up on this particular slide. But once that authentication is complete, they negotiate or they transmit all their traffic between these two sites using IPsec. Okay, but one of the things about it is IPsec is not a protocol. It's a standard or it's a collection of protocols or it's a protocol suite. Let's put it that way. Okay, are you able to hear me?
Yes, very well.
Okay. Now, because I hear some sort of noise, a background noise from your end.
Oh.
Okay.
Yeah. Shall I put it on mute? Let me put it on mute.
Yeah. Okay. No problem. Yeah. So at any point of time, if you're not able to hear me, just send me a message on chat, and I should be able to see that. Okay. Yeah. So as I was saying, the IPsec SA is what is established, or the security association that is established between these two peers, so that all the traffic that is exiting out of this ASA will be encrypted across this particular cloud, and then it will decrypt it on this particular peer. Okay. So I'll not spend time talking about the capacity and the performance of the ASA firewall models, because that's not the intention, or that's not the objective of this particular session. So I might as well skip this out, or just let me know if you want to go over this, or if you want to have a quick look at it. Okay. Yeah. So let's now talk about, when it comes to the deployment aspect of the ASA firewalls or the site-to-site VPN. So the first basic aspect is, like I said, you need to think about the peer authentication, which could be either pre-shared key or it could be digital certificates. Okay. The next important aspect would be the transmission protection. Now, this is where we are looking at the IPsec protocol suite. What I mean by that is, under IPsec, we have ESP, that's encapsulating security payload, and the other option that we have is authentication header. Now, of course, primarily, we would prefer to use ESP, because ESP is one protocol, or encapsulating security payload is the one which provides you with authentication as well as encryption, or it provides you with confidentiality, integrity, as well as replay protection. So basically those parameters, or like the encryption algorithm, the hashing algorithm, these have to match at both ends, right? So that's what we typically configure as part of the transmission protection. Also, when it comes to the peer authentication, even those credentials have to be exchanged as part of phase one over the internet in a secure fashion. So again, negotiation of those encryption algorithms, hashing algorithms for maintaining the confidentiality and integrity of the authentication credentials. Again, those parameters have to match between the two peers. And once these two aspects have been configured between the peers, and once they match, then the two peers are going to negotiate the parameters between them. And finally, we'll have a secure communication across the internet. Now, that secure communication is done using a secure channel, and that's nothing but the encrypted tunnel. So what I'll do next is, I'll just quickly go over the design and implementation guidelines when it comes to deploying the VPN. Okay. Now, when I talk about site-to-site VPN, it is not necessary that it's a VPN only between two sites. Okay. It could be like a scenario where we have a hub and spoke kind of a deployment, where we have an HQ site which has VPN tunnels connected with all its branches. Like there may be multiple branches out there. So it could be typically like a star topology or a hub and spoke topology that we can deploy using the site-to-site VPN. Okay. So the very first thing, like I mentioned earlier, is you need to verify the connectivity before you can encrypt the traffic. One of the aspects, or one of the reasons why we consider this as an important guideline, before we deploy VPN, is it becomes really difficult to troubleshoot any kind of connectivity issues after we deploy the VPN. In the sense, like all traffic that is going to pass through after the deployment of VPN is going to be encrypted. So which means we are now talking about an additional layer of troubleshooting. Okay, apart from the regular routing or the regular IP connectivity troubleshooting, we are also looking at the encryption or hashing algorithms or whatever additional security mechanisms we have put up in place. So even before we do the config, we need to make sure that all of our reachability issues are taken care of between the peers. The next important aspect now, if you're going to make use of pre-shared key, this is one parameter which needs to match at both ends. Okay, but then there is a slight consideration with regards to pre-shared key as well. I mean, there is that IKEv1 and IKEv2. IKEv1 is basically an old deployment or an old method that is available. But then the concept of IKEv1 was we just used pre-shared key as a single password. A password like, for example, Cisco. Okay, that key or that password value had to match at both the peer ends. But that's not the case with regards to IKEv2. In IKEv2, the concept changed drastically in the sense there is that additional mechanism of mutual authentication rather than having a symmetric key authentication. Okay, I hope you understand the terminology that is symmetric key authentication. That is, the same key is being used at both ends. Whereas when I talk about mutual authentication, what we're referring to out there is asymmetric authentication, wherein both of them will have their own set of credentials, which they'll exchange with each other and they'll authenticate to each other. Okay, so that brings about more security as compared to a symmetric authentication. So you get that option of asymmetric authentication with regards to IKE version 2. Now we'll talk more about it when we go along, but yeah, that's what is like popularly used nowadays, IKE version 2. Okay. Another important aspect, since we are talking about IKE version 1 and IKE version 2, is the devices that you're utilizing also need to have support for that particular feature. You know, it's not like you just get an ASA and immediately it has support for both IKE version 1 and IKE version 2. It also depends on the software version that is running on those devices. So that's another important aspect, which again we'll go over as we go along. But yeah, that's something that you need to look out for. The next thing is, you know, when we talk about a star topology, we are talking about multiple tunnels originating from the HQ or terminating on the HQ. So in that case, it would be a good idea to have separate pre-shared keys or separate credential parameters between HQ and branch 1 and between HQ and branch 2. So which means even though the endpoint or the edge device that is there or that is being utilized at HQ is one single device, but it should use different credentials for different branches. Okay, so that could be another aspect that we need to look out for. So another important aspect is avoid unnecessary complexity. Okay, because when we talk about a star topology, we are talking about, you know, depending upon the branches, we need to have that many number of tunnels associated with it. So naturally, it's going to be proportionately rising. And also, majority of the times, enterprise networks also deal with or also look into establishing a full mesh VPN connection. You know, so in that case, the number of VPN tunnels would be very high, depending upon the number of sites. So that's another important aspect. So try to keep it as simple as possible. And of course, use strong keys, you know, especially if you're going to make use of pre-shared key. Okay. But of course, pre-shared key is like an old technique or a basic kind of an authentication mechanism. We'll jump to digital certificates, which is a more secure mechanism. So let's take a quick look at the peer authentication parameters or the peer authentication configuration when it comes to the ASA firewall. Okay. Now, in this particular session, we are going to focus both on configuration of a router as well as configuration of a firewall. But at least the presentation that I'm running out here is only focusing on the ASA aspect. Okay. So the router is something that we'll look into when we get to the digital aspect or when we get to the configuration on the GNS3 and when we start working on the lab scenario. So let's take a look at the peer authentication with regards to IKE version 1. So as you could see, the peer authentication happens as part of phase 1. Okay. Now, one of the main things that you need to understand is this phase 1, phase 2 that I'm mentioning out here is only with regards to IKE version 1, because in IKE version 2, the concept of negotiation changes completely, which we'll discuss when we get to the IKE version 2. But yeah, so since we're talking about IKE version 1, or especially in the phase 1, the phase 1 is also called as main mode, wherein what it really does is the two peers, okay, we would name them as initiator and responder, where initiator is the peer through which the traffic is starting off, first of all. Okay, the VPN traffic or the interesting traffic which we mentioned, that is what initiates from this particular peer and is going to terminate on the other end of the tunnel, that is the responder end. Okay. So what it's going to do is at the initiator, it is going to go through all of its proposals and is going to match it or try to match it against the proposals that have been configured at the responder end. Now, what are these proposals? These proposals, in terms of configuration, are nothing but the ISAKMP policies that you configure on the devices. So whenever we talk about the ASA firewall, we configure some ISAKMP policies, which basically define the authentication method, the encryption algorithm, the hashing algorithm that we make use of, the key exchange group, that is the Diffie-Hellman group that we talk about. So all those parameters are defined under the proposals, and it could be possible that sometimes, you know, a single peer may have multiple proposals or multiple policies configured on it, each policy having its own set of configurations or own set of parameters under it. So each of those proposals or policies would be matched, or it'll try to match it against the other peer or the neighboring peer. And once it finds a match, the other peer is going to accept it, and accordingly they are going to negotiate that particular phase 1 SA. That's the security association related to phase 1. So once they have negotiated the SA, or once they have matched all the necessary parameters, they are going to now transmit or exchange the session key. Now that session key is what is exchanged with the help of the Diffie-Hellman group. Okay, and this was one of the parameters that was defined as part of the proposal. So that's the reason the matching of the parameters become absolutely important before we go on for the authentication. Okay, so once this Diffie-Hellman exchange is also successful, that's when they are going to exchange the pre-shared key with each other. Now the same logic even applies to the digital certificates as well. But again, we are going to talk more about digital certificates when we get to that portion. But Diffie-Hellman algorithm plays an important role when it comes to exchanging these authentication credentials. So once these credentials have been exchanged in a secure fashion, that's when these two peers establish the ISAKMP SA, or the Internet Security Association Key Management Protocol SA, or it can also be referred to as Main Mode SA, or Main Mode Security Association. Okay. So like I was mentioning, IKEv1 was the old methodology that was implemented, but let's now talk about IKEv2. IKEv2 basically is an enhancement with regards to IKEv1, in the sense it adds some new features to the existing IKEv1 implementation. In the sense, one of the main things would be it uses the same kind of config like what we have in IKEv1, but rather than having two separate SAs that we have, like we have phase 1 SA, phase 2 SA, and stuff like that in IKEv1, but in IKEv2, okay, everything is combined together or collated together into one single SA. I'll explain it further when we get to the next slide, but that's one of the main things that it has done. I mean, it has combined the SAs together to form a parent SA and a child SA kind of concept. It's not like two independent or two separate SAs that is configured out here, okay? So as far as configuration is concerned, I mean, the parameters are concerned, they do not change really, but it's just that when it comes to pre-shared key or credentials, you can have separate credentials on each and every peer. So which means peer 1 can have, let's say, the pre-shared key as Cisco, and peer 2 or the other peer can have a pre-shared key of Cisco 1. So Cisco and Cisco 1, and they'll exchange it between them, and that's how they can get mutually authenticated rather than having a symmetric authentication. So as you could see here, okay, so like I mentioned, IKEv2 enables you to configure asymmetric authentication method. Okay, so that's the main advantage of using IKEv2. It makes the authentication mechanism stronger as compared to IKEv1. Okay, so even if you're using a pre-shared key, it makes things stronger. But again, a pre-shared key is still a password, right? So that's where digital certificates could be a much better option. Okay, but yeah, another important aspect is when it comes to IKEv2, it does not negotiate what authentication type you're going to make use of. Like in IKEv1, we had to clearly define the authentication method in the policies, but that's not really needed when it comes to IKEv2. In the case of IKEv2, there is some sort of a policy negotiation, but it's not about the authentication type that it's going to negotiate. It's just going to exchange its own credentials that it knows about. So there is that mutual authentication, right? So that takes care of the checking of the credentials and authenticating to each other. So as you could see here, the authentication type for the responder is determined when a tunnel group mapping takes place. Now, this tunnel group mapping is nothing but the mapping of the credentials or the matching of the credentials at both ends. So when it comes to IKEv2, like I said, they do not have the concept of two independent or two separate SAs out here. Instead, what they have is they have the init message or the IKE init message, wherein they'll try to negotiate the various security parameters. Again, let me repeat. when they are negotiating parameters here, they are not negotiating the authentication type. They are just negotiating the security parameters like the encryption algorithm, the hashing algorithm, the Diffie-Hellman exchange method, and stuff like that. Okay, so they'll negotiate those security parameters, which are basically like two messages. So they'll exchange the Diffie-Hellman keys and the encrypted nonces if you're utilizing that. But yeah, the bottom line is they are going to exchange or establish the Diffie-Hellman session out there between the two peers. Now, optionally, they do have a cookie challenge. The concept of this cookie challenge comes in with regards to IKE version 2. That is like an additional mechanism of protection against DOS attacks or denial of service attacks, wherein people can try to spoof the session. Okay, so that spoofing can be avoided because along with the messages, it's going to also generate its own cookies, and that is what it's going to utilize at every point of time. So even if someone tries to generate or spoof the cookies, okay, these cookies have a random timeout or a specific timeout that they work upon. So at random intervals, the cookies are regenerated within the ASA firewall, and that makes the entire negotiation process more secure as compared to the regular exchange or regular negotiation process. But once that SA init is done with the help of two messages, it goes on into the next section wherein it tries to authenticate, or it carries out the mutual authentication, which is again a set of two messages. But what it really does out here is it has already established the IKE SA out here, which is a parent SA, and within that then it's going to then create the child SA, which is nothing but the IPsec SA. So this is what I was talking about earlier. In the case of IKE version 1, there was phase 1 SA first, wherein they try to get authenticated, and then once the authentication is complete, they start negotiating phase 2. But in IKE version 2, that's not the case at all. They first negotiate the security parameters. Once that parent SA has been established, within that SA itself, they are going to initiate a new child SA, which is nothing but the IPsec SA, where all the traffic would be protected or secured, or a secure tunnel is established on that. So talking about the configuration task, like I mentioned, you have to clearly, first of all, define whether you want to use IKE version 1 or IKE version 2. Or in some cases, you may want to use both of them. Again, it all depends on what kind of a technique or what kind of a scenario you have at hand. But that's what you need to do. Now, one of the things about this is typically you would enable this IKE version 1 or IKE version 2 on the external interface. Like in this example, the interface which is connected to the internet, that's the interface where you're going to enable it. So you have to specifically make sure that this IKE version 1 or IKE version 2 has been enabled on the external facing interface. Okay. Now, on an ASA firewall, you have to do this manually, or you have to enable this IKE version 1 or IKE version 2 manually. But if I talk about a Cisco router, the IKE version 1 or IKE version 2 is running by default. So you need not worry about enabling them separately. Okay, so it's something that is running already, provided on the router the appropriate security features have been activated. That's the only thing that you need to be concerned about when it comes to that. Okay, ASA firewall, again, the same thing. You need to have the appropriate license so that you can configure the VPN. Okay, so that's another aspect that you need to look out for. Then you go ahead and configure the IKE policies, and finally you'll configure the authentication credentials. So let's take a look at the example with regards to that. Now, of course, here they're talking about with regards to the GUI interface, where basically you need to configure a connection profile. And like I told you earlier, the very first step is you have to enable IKE version 1 or IKE version 2 on the appropriate interface. Now, on this firewall screenshot that they're showing up out here, there are two interfaces. One is named as outside and the other one is inside. So naturally, the outside would be the one which may be connected to the internet, and that's where they are going to enable IKE version 1 as well as IKE version 2. And then the next important thing is you need to define the various IKE parameters. Now, when it comes to defining the IKE parameters, we are talking about IKE identity or pre-shared key information that you want to send, like IP address or the pre-shared key value and stuff like that. So that's what you need to do next. Okay. So, but then when it comes to the GUI, you need not really configure it all the time. In the sense, the GUI makes sure that there are some default parameters that it can make use of. So it can automatically activate those default parameters. But if you're trying to do it through the CLI, you need to make sure that you enable or define all those parameters before you start the VPN negotiation. So as you can see here, these are all the IKE version 1 policies. So as I told you earlier, these are already there. It's not like you have to go ahead and add them. But yeah, if at all the firewall does not have it, you need to go ahead and manually configure it. Same thing applies for IKE version 2. But the main thing about IKE version 2 is there is a set of default policies. I mean, a policy by the name of default, which is already there on the ASA firewall. So if at all those default policy parameters do not match your requirements, you need to go ahead and add your own policies out there. But these are nothing but the SA parameters which they are going to negotiate between the two peers. So I hope at this point of time you're able to follow whatever is going on out here. Okay. Yeah, so that's a screenshot of the parameters or the policy parameters that you define under IKE version 1 and IKE version 2. So as you could see, you have similar options between these two, but one of the main differences is in IKE version 1, you have the authentication method which you need to define. But in the case of IKE version 2, like we discussed earlier, the authentication method need not be defined. It's something that is given out by the responder. The responder is giving out this information, and based on that, the initiator will go ahead and do the appropriate authentication with that. So the only parameters that you define on the IKE version 2 is the encryption value, the Diffie-Hellman group of what Diffie-Hellman group you want to utilize, the hashing algorithm. Then there is a pseudo-random function or a PRF hash. Okay. Now this PRF hash, when I talk about it, it is more or less like the PFS group, which you configure on the router. Okay, which is like an additional layer of protection when it comes to the credentials or the credential information that you're trying to exchange between the two peers. Then you can also have the option of lifetime that you can define out here, which by default is 86,400 seconds, which is 24 hours. Okay. The next aspect that you need to define is the credential parameter itself. Like if you're going to make use of pre-shared key, you need to make sure that you define the pre-shared key. Same thing. I mean, both either in IKE version 1 as well as in IKE version 2, you need to make sure that you define the parameters out there. Like as you can see, there are two tabs out here. But before you even get on into this option, you need to go ahead and define a tunnel group. Now that is the way you define the peer IP address or the peer identity when it comes to the ASA firewall. So the peer identity is defined on an ASA firewall using a tunnel group. And that tunnel group typically points out to the public IP address of the remote peer. Okay, so in this example, the peer IP address happens to be 192.168.1.1. And under that, that's the group policy, which is basically defining the various attributes for the IPsec. Okay, because like I said, in IKE version 2, all the parameters are negotiated together, right? So naturally, it has to have a matching IPsec policy also related to that. But yeah, so you have the IKE version 1 settings which you can configure here, wherein as you could see, you have the pre-shared key option on top and then the device certificate below. Okay, device certificate is the one which is used for digital certificates, whereas pre-shared key is only the password that you define. But this is the IKE version 1. But if I talk about IKE version 2, okay, the settings are different. And as you can see, you have a local pre-shared key and a remote peer pre-shared key. Okay, but when it comes to digital certificates, you only have the option of local device certificate. Okay, and then you have remote peer certificate authentication, which you can allow it. So these two options are related to the certificate authentication, whereas these options like the local pre-shared key and the remote peer pre-shared key, these are for the asymmetric pre-shared key authentication. So that would be the next step, okay, when it comes to IKE version 2 parameters. Now, once you've done that, that's the command line equivalent. So like I mentioned earlier, as you can see in this example, we have the group policy. Yeah, tell me.
Okay, so if you go back one slide, I noticed that the name of the tunnel group is IP address. I remember reading somewhere in an article that is a better option to use instead of like a name. or word?
Yeah. Actually, the main thing is when it comes to the tunnel group name, okay, if you're going in for site-to-site VPN, it always is a good idea to define the IP address, okay? Because if you define a name, we are actually trying to refer to the peer using a DNS name or something like that. So which means you have that additional layer of name resolution which you need to depend upon, you know? So if at any point of time, if you have a DNS name resolution issue of some sort, then it becomes a problem, okay? But saying that, when I talk about the remote access VPN, of course, which is not the scope of this discussion, but let's say you go ahead and configure a remote access VPN, you have to give the tunnel group a name. IP address is not an option out there, okay? Because the tunnel group name represents the group name. So that's a different story when it comes to remote access, but for site-to-site, it's always recommended that you use an IP address. So I think that is what you were referring to, right? I mean, it's always good to use the IP address instead of a name.
Correct.
Yeah. Yeah. So it's just a matter of if you're using a name, you need to go in for that additional layer of name resolution, which means it brings about the dependency on a DNS server, right? So that can make things a bit complex because it's not necessary that you'll have a router name or a ASA firewall name registered on a public DNS server, right? Because we are talking about public IP addresses. So naturally, public IP addresses would be stored on the external DNS server, and if the peers have to resolve the names with each other, either they need to have a static configuration within themselves, or they have to rely on a DNS server. So just to avoid that additional reliance on a DNS, it's better to go in for the IP address. I hope I was able to clarify your question, yeah? Okay, so going forward, there you go. That's the equivalent command line when it comes to IKEv1 and IKEv2. So let me just quickly go over this entire aspect. So like I said, under IKEv1, you have to define the ISAKMP policy. That's nothing but this section here, crypto IKEv1 policy. And as you can see, encryption is defined as DES in this example, which is not a good idea. But I mean, considering this example here, they're using encryption of DES and authentication method of reshare. That is what they've defined here. But you don't see any other parameters like hashing, or you don't see the Diffie element group, because maybe they are using the defaults that are available within the ASA firewall. That is, by default, the hashing algorithm on an ASA firewall is SHA. Okay, so if you do not define it, it will use the default value of SHA. Same way for Diffie element group, by default it is group 2. So if you don't mention anything, it is going to use the Diffie element group 2. So that's what could be the case out here. They have not mentioned it, meaning it's using the default parameter values for those aspects. But that's for IKEv1. Similarly, for IKEv2, as you could see, they're defining the Diffie element group of 5 and encryption of AES 192-bit. Okay, so they are not relying on the basic encryption level. Now, that's another important aspect when it comes to IKEv2. IKEv2 does not support the basic encryption algorithm. They always work on the higher end, or in fact, they also give you the option of using the next generation encryption algorithm. Okay? But yeah, since it's an ASA firewall, you also need to make sure that you enable IKEv1 and IKEv2 on the appropriate interface. Okay. Once you've done that, the next step is you have to define the tunnel group. Now, when you're defining the tunnel group, you also need to make sure that the tunnel group needs to have an IP address of the peer, which we just had a look at, and then you have to define what type of a tunnel group it is. Now, the moment you type IPsec L2L, that L2L represents LAN to LAN or site to site. So this is what determines or identifies whether this tunnel is a site to site VPN tunnel, or whether it's going to be remote access or SSL VPN. So basically the tunnel group is the one which defines what kind of a VPN you're configuring out there. Once you've done that, you've defined that additional attribute, that is general attributes, and you'll define or map it to the group policy. Now, the group policy is where you'll define the tunnel protocol that you want to utilize, whether you want to utilize IKEv1 or IKEv2 or both of them. Like in this example, as you could see, they're using VPN tunnel protocol as IKEv1 space IKEv2, meaning it is capable of negotiating IKEv1 as well as IKEv2. Okay, so which means does not mean that both of them have to be negotiated. Basically, what it means is Okay, it is going to prefer IKEv2, but if the other peer does not have IKEv2 configured on that peer, it will fall back to IKEv1. Okay, so that's the whole idea, or that's the logic behind IKEv2 and IKEv1. So if at all you have a coexistence of IKEv2 and IKEv1, IKEv2 will have more preference, or that's the negotiation which will be preferred over IKEv1. Now these are the various credential information or the parameter configs with regards to the IKEv1 and IKEv2. As I told you earlier, IKEv1 just needs a symmetric pre-shared key, the same password which needs to be configured at both ends. But for IKEv2, you have to define a local authentication pre-shared key as well as a remote authentication pre-shared key, and that's what you see out here. So this is what brings about the mutual authentication when it comes to IKEv2, or asymmetric authentication. Now, that was the parent SA, or the phase 1 with regards to IKEv1. Now let's get on into the transmission protection, that is the phase 2 in IKEv1, wherein the actual traffic needs to get encrypted. So when it comes to that, there you go. So in the case of IKEv1, this phase 2 is called as quick mode. The phase 1 in IKEv1 was called main mode. So at the end of the main mode, they established the ISAKMP SA, right? But when we talk about phase 2 or the quick mode, it establishes the IPsec SA. Okay, but again, remember, the IPsec SA, when we talk about it, it's not exactly a protocol. Like ISAKMP was a protocol, but IPsec is a standard which defines a set of protocols which can be used for the negotiation. Okay, so those set of parameters is what you define under the IPsec proposal, which you need to configure between the initiator and the responder. So again, just like phase 1, they are going to match, or the initiator of the VPN is going to match the appropriate proposals with the peer, and depending upon a proposal match, they are going to negotiate those appropriate parameters and set up a secure channel between them through which your actual IP traffic, or interesting traffic as we call it, would be passed through. So here on, as soon as the IPsec SA is established, all traffic that is going to leave this peer is going to get to this responder or to this particular other peer in an encrypted fashion. Same way, whatever return traffic comes back will be encrypted between the two peers here, and it would be decrypted at this end here. But in IKEv2, like I mentioned, they go ahead and configure child SA. It's not a separate SA that you're configuring, or a separate SA that needs to be negotiated out here. Within the parent SA itself, it's going to negotiate another SA. Okay, that is what is called as a child SA, which is a set of 2 messages again. So what it really does is, it creates an additional child SA under the protection of the existing parent SA. That is typically used to rekey or re-authenticate or renegotiate parameters at certain interval of time. So that is what makes it more secure as compared to IKEv1. So in IKEv2, it's not just about the parameters, it's also about the process. The entire process with regards to IKEv2 is much more secure as compared to IKEv1, which makes it much more stronger as compared to IKEv1. Then there are those status and control messages which could be exchanged at regular interval, like keep alive maybe, or some clearing of old or outdated information, or clearing out some old keys that they had negotiated upon earlier, because the keys have to be renegotiated at a regular interval of time. So that is what is cleared out when the new key is generated. So all those aspects happen as part of creating the child SA. So remember, in IKEv1, we have ISAKMP SA as phase 1 and IPsec SA as phase 2. But in the case of IKEv2, we have the parent SA that is similar to the phase 1. Okay, but then we have an additional child SA, which is like an optional component for rekeying or stuff like that. Okay, so this is not where the actual traffic is getting encrypted or something. This is like an additional layer of a negotiation that it does, so that the keys are renegotiated or they are refreshed at regular interval of time. So when it comes to configuring the IKEv1 phase 2 parameters, okay, that is done with the help of a crypto map. But before we get on into this crypto map, you need to make sure that you define an IPsec proposal. Okay, so an IPsec proposal will have option of defining ESP or AH or what tunnel mode or transport mode you want to utilize for your phase 2. Now this we are talking about in terms of IKEv1. That's the reason we have the IKEv1 IPsec proposal. But yeah, that's what you need to define out here. So as you can see, under ESP, they are defining the encryption as well as the authentication or the hashing. Okay, so that's another parameter that you need to define out here. But then when it comes to IKEv2, okay, here we are defining again similar kind of parameters, okay, like the encryption and the hashing. Because again, in the case of IKEv2 also, it has to do that, or it has to encrypt the traffic or secure the traffic using IPsec. So naturally, those appropriate parameters have to be defined out there as well. And then those parameters, that is IKEv1 IPsec proposal as well as IKEv2 IPsec proposal, have to be defined under something called as a crypto map. So crypto map is basically mapping or combining these things like the transform set or the peer IP address and all of that under the single configuration parameter, which can then be applied to the appropriate interface. As you can see in this example here, they are applying it on the outside interface, and the policy type they are choosing static because it's not a dynamic negotiation. It's all dependent upon your configuration of the proposals, both IKEv1 as well as IKEv2 proposals. Okay, so that's what they're defining out here. They are also enabling something called as perfect forwarding secrecy. This is nothing but that additional layer of session protection that they get by making use of the Diffie-Hellman group or the Diffie-Hellman algorithm. The next aspect, like apart from configuring the tunnel group, you also need to define what traffic do you want to pass through the VPN. And this commonly is called as interesting traffic. Okay, and that's what they're defining out here. Like, as you can see, this traffic selection is common to both IKEv1 and IKEv2 because it's just a matter of protecting the traffic using the VPN. So that's what you define out here. Like, it can be IP traffic, it can be TCP traffic, but overall, it is the traffic that you want to protect or pass through the VPN tunnel. Okay, so that's what they're defining out here. So as you could see, when it comes to configuring the site-to-site VPN using the CLI, the process or the methods would be different as compared to when you do it through the GUI. In fact, when you do it through the GUI, you also have the choice of doing it through a VPN wizard. You need not rely on these individual components one by one and then going ahead and configuring it. You just go through a wizard, just follow all the steps that the wizard asks you for, define all the parameters that the wizard asks you for, and your VPN tunnel is up and running on a particular peer. Okay, so that's the main thing. When it comes to CLI, you get that more flexibility, whereas in the GUI, you do get the flexibility, but the order in which you do the configs may be a bit confusing at some points of time. Okay, and also troubleshooting can also become a bit difficult when it comes to working with the GUI. But of course, saying that at a personal level, I prefer to work at the CLI. Okay, so that's the command line equivalent when it comes to the phase 2 for IKEv1 or IKEv2 child SA. So as you could see here, they are creating an object. Now this object that they're creating is just to define the access list. Okay, so here they are defining that access list to define the interesting traffic, but for that the source and destination, they're doing it with the help of creating an object. Like here, the object, they've given it a name of remote branch, that is nothing but the remote subnet, and then they've created another object by the name internal. Now this internal is nothing but the predefined object which is there in the GUI, which defines your internal network. Okay, yeah, you do prefer the CLI, right? Yeah, it makes sense, it gives you that kind of flexibility out there. Okay, going forward, the next thing is for IKEv1, you define the transform set, which is what defines what ESP parameters or phase 2 parameters you want to make use of. And then for IKEv2, you define the IPsec proposal. So as you could see, the terminologies utilized for IKEv1 and IKEv2 are different, but ultimately, if you look at the configuration parameters, they are the same. Both of them are defining what ESP, encryption, and authentication do we want to utilize. So that's what they define out here. And then the next aspect is to define the crypto map, which combines all of these things together. Like as you can see, they're matching this access list here by typing match address outside underscore cryptomap underscore 1, where outside underscore cryptomap underscore 1 is nothing but the name of the access list. They are defining PFS, that is perfect forwarding secrecy, group 2, that's the Diffie-Hellman group 2, the peer IP address, and then they're defining the version 1 and the version 2 IPsec proposal and the transform set, and ultimately they are applying this cryptomap on the outside interface. Okay. Now, of course, here they are showing you the CLI corresponding to the GUI configs which we had a look at in the previous slides. Okay, but that's the whole idea about here. So there you go. So that's a summary of the connection profile in general. So as you can see, under this one single location itself, you're able to see the entire set of configs. Like that's a protected network, which is nothing but your interesting traffic. That's your tunnel group IP address, which at this point you're not able to modify because it's already done earlier, right? So that's what you see out here. Under IKE version 1, you could see the credentials defined as well as the IKE policy. And as you could see, it's giving you a long list of different IKE policies plus the IPsec proposal that was been added. But similarly, when you click on the IKE version 2 settings, you'll see the parameters associated with that. Okay, so there you go. They clicked on the IPsec proposal, and as you could see, it is giving you a long list of all the different IPsec proposals that are already there, plus the one that was configured. Like V1 proposal and V2 proposal was just configured. So you could see both of them. Now, when it comes to the CLI, let's assume that you already had an IKE version 1 config out there on your ASA firewall, and let's say you want to quickly move over or migrate towards an IKE version 2. So in that case, there is a command on the ASA firewall which allows you to do a quick migration from IKE version 1 to IKE version 2. Okay, so rather than just like, configuring everything right from scratch, you just run the single command migrate, and then you define what type of VPN do you want to migrate, like L2L, that is LAN to LAN, and remote access, that's for remote access VPN. So you define LAN to LAN, let's say, so migrate LAN to LAN, and then you define whether you want to use the SSL or IKE version 2 VPN. So you just type migrate L2L IKE version 2, and the moment you do that, you'll notice, okay, your existing LAN to LAN, which was configured for IKE version 1, would be migrated or would be changed over to IKE version 2. So, any VPN you may have, site-to-site or remote access. Okay, under remote access also you have IPsec as well as SSL, but you can migrate it accordingly. The firewall gives you that capability of doing the migration automatically. Okay. Now, of course, this is a CLI option. You do not have a GUI option wherein you can directly go ahead and do the migration. There is an option out there, but it's a kind of complex, so it's much better to do it through the CLI. Now, let's quickly go over certain aspects with regards to troubleshooting as well. Now, troubleshooting mainly would involve troubleshooting the configs that you've configured. Okay, so let's take a quick look at that aspect as well. Okay, so when it comes to troubleshooting across the VPN, ping and traceroute are like common commands that you can go for. But when it comes to the GUI is called ASDM, right? So in that case, you have the ASDM log viewer, which will allow you to give, which shows you real-time logs as to what's exactly happening on the ASA firewall. But apart from that, you also have some show commands by which you can troubleshoot the VPN through the CLI, like the show logging will, of course, show you the logs on the ASA firewall. But show route is another option that is available. Okay, this is basically to look at the routing table. Show crypto ISAKMP SA, that's to look at the phase 1 for IKE version 1, and show crypto IPsec SA, that's for phase 2 for IKE version 1. And then you have the debug commands like phase 1 and phase 2, which you can debug out here. But remember, when it comes to the ASA firewall, when you do a debug, you cannot see the log messages on the ASA firewall itself, because by default, it does not show you those messages. So you'll have to go into show logging to actually view those messages out there. Just a minute, please. Hey, sorry about that. I'm back. Okay, so I was saying, or I was talking about the various troubleshooting commands and options that are available out here. Okay, so yeah, so these are options, but the special consideration for the debug, not like the router where you could see the real-time messages on the screen itself. You have to type show logging to look at all the log messages, or you'll have to enable the logging manually so that you can see all those messages on the console. Now, going forward, there you go. That's the output which you'll see when it comes to IKE version 1. As you can see in this example, the show crypto ISAKMP SA detail clearly tells you about the active SA, wherein it tells you the type is LAN to LAN. So as you can see in this example, in this case, the ASA as a peer has established IKE version 1 SA. It has not established any IKE version 2, maybe because the other peer may not be configured for IKE version 2. Because if at all the other peer also would have been configured for IKE version 2, it would have preferred that, right, which I mentioned earlier. So in this case, they have negotiated IKE version 1. So that's why you can see the peer IP address, the type of VPN that is configured is L2L or LAN to LAN. The role in this case is responder. So which means this ASA firewall which we are looking at right now is the responder as compared to the other peer, which would be the initiator. Rekey, there is no such feature configured when it comes to IKE version 1, so that's why it shows no. But the state, it shows mm_active, where mm out here represents main mode. So it's definitely saying that the main mode is active, or the main mode has been negotiated successfully. The encryption algorithm that they have negotiated is AES-256, and the hashing is SHA. But if you remember the earlier configs, when we went through the previous slide, you might have noticed the manual configuration, when it was showing that, it was showing the encryption method to be DES. But here, the encryption that it has negotiated is AES-256. Well, again, there's that aspect also. Whenever you configure that phase 1 SA or the ISAKMP policy or the IKE version 1 policy, you define a sequence number. So the matching of the proposals, between the peers happen on the basis of a sequence number. Like it starts off at sequence number 1, 2, 3, and so on, right? So if it finds a better match with regards to some sequence number which is lower, it will prefer to use that. Maybe that is what happened in this example, like AES-256 was negotiated because maybe this proposal was at a higher level as compared to the one that we had configured earlier. Authentication method, as you can see, it's pre-shared. Lifetime is 86,400, but out of that, the lifetime remaining is 86,295 because it's a countdown that initiates, right, as soon as the SA is established. Now that's the IPsec SA, which clearly tells you about whether the traffic has really passed through the tunnel. Now this is where it will tell you how many packets have been encapsulated and decapsulated, or encrypted and decrypted, and digested and verified. So basically, it's telling you whether all the traffic has really passed through the VPN tunnel. Okay. Now, this is what I was mentioning earlier. When it comes to logging on the ASA firewall, it's a bit different as compared to a Cisco router. On a Cisco router, the logging for the console is already enabled, but on an ASA firewall, you have to manually type in this kind of a command, like logging console, and here they have enabled the logging on the console for debugging messages, where 7 out here represents debugging messages, and you have to type logging enable so that the messages appear on the console. That's the reason, like when you work with the CLI on the ASA firewall, let's say you go ahead and enable an interface, you don't see those corresponding console messages out there. Okay, that's because by default, the console logging is disabled. So you need to make sure that you go ahead and enable it, and then you'll be able to see those appropriate messages. Now, in this case, what it's talking about is, as soon as they enable the logging out here on this ASA firewall, it's talking about some sort of phase 1 failure, wherein mismatched attribute types for the class group description is received group 2, but the configured is group 1. Basically, there's a Diffie-Hellman group mismatch out here. What it's saying is the peer has been configured, like this ASA firewall has been configured with a group of 1, whereas the other peer or the other device out there at the other end has given it or sent out a proposal with the group value of 2. So that's a mismatch, and because of which the negotiation has failed. Okay, so that's what comes up because the IKE proposal has not matched at both ends. Now this is a message which you'd get if at all the pre-shared key or the authentication parameter is not matching. Okay. So as you can see in this example, it's clearly saying had problems decrypting the packet, probably due to mismatched pre-shared key, and it's aborting it. So phase 1 itself is aborting. Now that's another important aspect when it comes to VPN negotiation. A VPN tunnel is established in the order of phase 1 first, and then it goes on into phase 2. So if the phase 1 fails, it will never start negotiation of phase 2. That's the main thing about it. Okay, so for a VPN tunnel to be successfully established, phase 1 negotiation is what happens first, and then it goes on into phase 2. There you go. That's another set of log messages that you see out here. So in this case, again, when you look at the log messages, it's talking about group equal to 192.168.1.1 and generating quick mode key. Basically, it's going over or switching over to phase 2. That is what it makes sure with the help of this particular command. And then it's saying an outbound LAN to LAN SA between this IP and this IP, where this IP is a peer and this is its own public IP maybe, and it's saying has been created. User equal to 10.0.1.11. Now, don't think that this user equal to represents a username or something. It's just representing some sort of an internal client that they're talking about out there. Okay, some internal machine who was trying to send out the interesting traffic. So that source IP is what came in, and based on that, it established the phase 2, because here it clearly says security negotiation complete for the LAN to LAN group of this IP, and inbound SPI and outbound SPI has been created, where SPI is security parameter index. So it has clearly indicated that it has created an inbound as well as an outbound phase 2 SA. And apart from that, it clearly gives you a message which says phase 2 completed between these two, between the group or with the tunnel group of 192.168.1.1. Okay. So like I mentioned, these are the debug messages that you can configure or make use of for troubleshooting site-to-site VPN. But as a general guideline, debug is always useful only, I would say primarily for VPN connectivity. Okay. And that's the reason it becomes absolutely crucial for you to troubleshoot any kind of connectivity issues before you go ahead and start working on the VPN aspect or the VPN troubleshooting. Okay. So yeah, the debug messages like debug crypto ISAKMP and debug crypto IPsec will make sure that it gives you the appropriate messages with regards to the negotiation related to ISAKMP and IPsec. You also have the clear commands like clear crypto IKEv1 and clear crypto IKEv2. Now this is for IKEv1 and IKEv2 if you want to clear out the SA. Okay. If you do a clear crypto IKEv1, it is going to clear out both phase 2 as well as phase 1, because like I told you, phase 2 cannot work without phase 1, right? So that's what this command really does. And in IKEv2, there is no concept of phase 1 and phase 2. So naturally, it's going to clear out the SA directly by typing in clear crypto IKEv2. So that was this section, just giving an understanding of the site-to-site VPN and stuff like that. So what I'll do right now is I'll just pause the recording right now. Okay, you can turn on your microphone. Okay, so there you go. The recording starts. So yeah, now what we'll do is we'll get over to the next section of the topic. Okay, wherein we'll take a look at advanced site-to-site IPsec VPN. Okay, now this is where we actually would focus on things like advanced security, like pre-shared key having its own limitations and stuff like that. Okay, so let's take a look at the various configuration choices and options that are available. Yeah, so when it comes to site-to-site VPN, pre-shared key is what we talked about earlier. Excuse me. But when it comes to site-to-site VPN, a better option or a much more scalable and a secure option that is available is certificate authentication. Okay. Now, why do I call it scalable? The reason I call it scalable is because, irrespective of the number of sites that you have, okay, you need not worry about configuring pre-shared keys that are matching between the peers and stuff like that. You just need to have an appropriate certificate, okay, a digital certificate from a server called as a certificate authority. So the CA, which you see out here, is nothing but the certificate authority. So that's the server which is going to issue certificates to both of these peers. Okay, now that's one of the major aspects when it comes to deploying digital certificates. The peers who are going to involve themselves in setting up the VPN tunnel need to receive certificates from the same certificate authority. Okay, so practically when I talk about it, let's assume if I have subscribed to or if I purchased a certificate from, let's say, a vendor like F-Secure, so in that case, my peer also needs to have a certificate from the same certificate vendor, that is F-Secure, without which it is, we both won't be able to authenticate to each other. Okay, so the issuer has to be common for both of our certificates to be trusted, and that's the whole idea. But sometimes, when I talk about online certificate authority, if I'm not using my own servers, for example, if I'm relying on online certificate authorities like F-Secure, for example, in that case, these online certificate authorities trust each other. Like there can be vendors like VeriSign, then there is another company called as Sto-to-Ste or Baltimore, or then there is F-Secure, like I mentioned earlier. There are lots of online certificate vendors, right? So these vendors, some of them at least, trust each other. So in that case, you need not have certificates issued from the same vendor in that case. Since the vendors themselves trust each other, even if the peers have got the certificates from the trusted vendors, and as long as they receive it from trusted vendors, you can see to it that the authentication happens with each other. Okay, and that's the reason, or that's what happens like globally online. The two administrators at two different sites have to just verify that the certificates are coming in from like mutually trusted vendors. Okay, that's the main thing about it. Now, let's talk about these certificates a bit more. So basically, when I talk about these certificates, they are nothing but some electronic files that are given out or electronic keys that are distributed by the certificate authority server. Like I mentioned, it can be an online certificate authority server, or it could be your own CS server that you're deploying. Like in our discussion or in our lab environment, we are going to set up our own 2008 server. Okay, that 2008 server can be acting as a CS server. Or in fact, we can also have an option of configuring a Cisco router as a CS server. Okay, so would you be interested in looking at 2008 server as a CS server, or would you be interested in looking at a router as a CS server? Okay. So yeah, so in that case, that's what we'll do. We'll use the 2008 server as a CS server, which I mentioned earlier. Like I have a virtual machine of 2008 running. So we'll integrate that under GNS3, and that's how we'll do the setup. Okay. So we'll get to that point a bit later, but then the primary thing is, we need to have the CS server up and running on the 2008 server. But apart from that, these two devices also need to request and receive a certificate from the CS server. Now that's where you need to understand two different types of keys, or two terms related to keys. One is called as a private key, and the other one is called as a public key. Okay, so one of the keys is private, which means you cannot share it, or you're not supposed to share it with anyone. Okay, it's for your own personal identity information or personal use. And then there is a public key, which is something that you exchange with other users or other devices with whom you want to authenticate yourself, maybe. Okay, so that's the main thing. So each of these peers will have their own private key, and they'll also have their public key. So whenever these peers request for a certificate from the certificate authority, what they are really doing is, okay, first of all, they have to generate their own private key. Within the devices themselves, they'll generate their own private key. So as part of the configuration, you'll notice we have to go ahead and generate some keys within the devices. So that key that we're generating within the device is nothing but the private key. But then using that private key, they are going to send out a request to this certificate authority. But how are they going to send out that request? Before sending out that request, they have to go ahead and download the CA's public key, or it's also called as a root certificate, okay, or also called as the CA certificate. So the ASA firewall needs to download a CA certificate from the CA server. Now remember, that CA certificate which they are downloading from the CA server is not the private key of the CA server. The CA server will have its own private key, but the CA certificate is nothing but a public key of the CA server. So that public key is what they'll try to download into their device. Okay. Now for downloading the CA certificate, they'll have to provide their own information. Okay. So that information will be taken up from the private key that they have. So they'll provide their information, download the CA certificate, and then when they're generating that request for a certificate from the CA server, okay, that certificate which they'll get would be a public key, like I mentioned. So that public key information or that public key which they'll receive, okay, will be based upon the private key information that they sent across to the CA server. So that's how the CA server knows that, okay, this is peer 1 and maybe this device is peer 2. Okay, so again, let me repeat, the certificate that they receive from the CA server, they'll receive it only after they download the CA certificate. So the CA certificate would be the first certificate that they need to download. And then based on that, they'll generate and send out a request for an identity certificate, that is their own identity information certificate, which is nothing but the public key which they receive from this particular CA server. Okay, so both of these peers have to authenticate and enroll for an identity certificate, which is what you see out here. And this key which you see out here is nothing but the exchange of these public key between the two peers. So it is on the basis of the exchange of the public keys that they're able to authenticate with each other. Okay, we'll talk more about it as we go along, but the logic is the devices that are going to participate, in this authentication process need to have a certificate from a common trusted CA server. Okay, so that CA server can be a router, it can be a Windows server, or it could be a Linux server, but the point is it has to be from a common trusted CA server. Okay, so based on that particular certificate that they have now, they'll exchange that identity certificate and they'll carry out peer authentication that will bring about ISAKMP, and then rest of the process would be as similar, it's exactly similar to what we talked about with regards to pre-shared key. So the only change out here in this entire process would be they have to make sure that they download and receive the certificate from the CA server, both the CA certificate as well as their own identity certificate, and then they have to authenticate using that certificate. Now, how do these certificates operate? Let's talk about that now. When we created a pre-shared key earlier, it was just a static password, right, which you configured. There was no lifetime to it or there's no expiry to it. But when it comes to a certificate, one of the main things that you need to absolutely understand with regards to digital certificates is the digital certificates have an expiry or a lifetime to it. Okay, and that's the reason it becomes all the more important that the devices that we talk about out here need to be synchronized to an NTP server. Either they need to be synchronized to an NTP server, or you need to make sure that the devices have the correct time configured on them. Because if the devices do not have a correct time, okay, which means, let's say, by default, when you go into an ASA firewall or a router sometimes, you see that the clock settings on that particular device is dated back to 2008 or sometimes 2005 or even sometimes 1993, So if the device clock settings have not been changed or if they are not synchronized to the correct clock settings, maybe when they download the certificate may not be even active during that point of time, because when they download the certificate, it would be according to today's date, that is 2016, and the router clock or device clock is set according to 2008. In that case, since the clock settings are not good enough, the certificate will not be valid. Okay, so just to make sure that the certificate is valid, you need to make sure that the device clock settings are up to date. And that's why it becomes important that the devices are synchronized to a NTP server, because it becomes easier for us to synchronize the clock settings using an NTP server as compared to setting up the clock manually. Now, a tolerance level of around 2 or 3 minutes or up to 5 minutes, let's say, is still all right. But if at all we are talking about a delay or a time difference of around 1 hour or years, days, or months, then that's not at all tolerable, because the certificate may not be active during that point of time. Okay, so that's the reason it's normally recommended that you make use of an NTP server. Even in a production environment or in a practical scenario, we do have NTP servers online or NTP servers that are available on the internet. So you can make sure that the clock settings on the device is synchronized based on the NTP servers on the internet, and then that device can act as an NTP server for all of your internal devices. Okay, so that's typically one of the ways in which you can do the config. Okay, now let me ask you a question. In your scenario, do you ever deploy remote access VPN? Okay, so when it comes to remote access VPN, then if you're going to use certificates for remote access VPN, then in that case, we are not installing the certificate on the router or the firewall. Instead, we are installing it on the individual PC. So in that case, the clock need not be worried about, because since the machine is connected to the internet, naturally it will derive its clock settings from either the Windows server or whatever operating system it's running on. So every operating system has its own NTP client config, which will make sure that the clock settings are good. Of course, there are those other aspects of the hardware clock, the battery of the computer going bad or something, but that's like a exceptional case, But majority of the times, the operating system makes sure that the clock settings on that particular device is good. So which means you would be able to download and use the certificate according to that. Okay. So even when we start working on the digital certificate, we'll make sure that our devices have the appropriate clock settings from a common NTP server. Okay. So that would be one of the things that we'll be working upon. Now, going forward, so these are the things that you need to make sure that you do whenever it comes to PKI-based authentication. Now, what is this PKI? PKI is nothing but public key infrastructure. But what is this public key infrastructure? It is nothing but a collection of these services, the CA server, okay, the CA certificate, the identity certificate, the devices authenticating and enrolling to the CA server and requesting for the identity certificate, installing them, okay. So all this together forms the PKI, or the public key infrastructure. Okay. Now, of course, in this topology diagram or in this diagram, you only see one server, but it's not always necessary that you'll have a single server. You may have something called as a root CA, that is a CA server right at the top level, and then you may have subordinate CAs, which are useful for redundancy or load balancing, the service of the CA server, wherein the subordinate CA would be the one which will be placed at a remote location, and then the CA server would be placed at a central location, and sometimes it may be kept offline. So in that case, the subordinate CA would be the one authenticating and issuing the certificates to the appropriate requesting devices. Okay, so that's another important aspect. Now, of course, there are something more that I need to talk about with regards to the CA server, which I'll talk about in a little while. Let's first focus on the configuration aspect, and then when we get to the lab environment, that's where I need to talk more about setting up the CA server. Okay, but I'm assuming at this point you may not be involved much with setting up a CA server, right? Oh, okay, you have already set up. Okay, but there are some considerations for setting up a CA server. When it comes to setting up a CA server, it's not just a matter of installing the CA service role. There are more things to it. So yes, that I'll talk about when we start working on the lab environment.
Yes, very good. Yeah, that's the type of detail that I look forward to understanding further.
Oh, okay. So that, yeah, then in that case, yeah. In my case, in my lab environment, I've already set up that server completely according to the way it's supposed to be. But I'll definitely go over the details, and I'll definitely talk about how we can set that up. Okay, because just installing the role will not make sure that the devices like a ASA firewall or a router will receive it. For the ASA and router to receive the certificate, we need to do some additional config, so which we'll go over when we get to that point. Okay, but right now, let's quickly go over the configuration steps on the ASA firewall. Okay, so when it comes to that, just like the pre-shared key, you have to go ahead and configure the connection profile. You have to define the interesting traffic. You have to configure the IKE policy. But if you look at the configuration tasks out here, they define choosing the identity certificate as step number 4. So that's where the first and foremost thing that you need to make sure is, even before you start configuring PKI-based authentication, you need to make sure that the device itself has received a certificate, that is the identity certificate from the CA server. And that's where those steps which I mentioned earlier of generating its own key internally, that is generating the private key first, or even before that, setting up the clock settings, setting up the name, setting up the appropriate parameters of synchronization with the NTP server, then making sure that the key is generated right, the key has no problems with it, making sure that it has connectivity with the CA server. Then you go ahead and download the CA certificate, request for an identity certificate, download and install the identity certificate. All those steps have to be taken care of before you even start off with the config. And that's what we are going to look forward to in the lab portion of things. Okay, but right now, with regards to the configuration, that's what you would do. So you'll have to choose the identity certificate, but you'll have to make sure that even before you start the config of the VPN, the certificates are already there in place on the device. Okay, so you have to choose the identity certificate, you have to configure the transform set, you have to configure the crypto map parameters or the tunnel group parameters, and additional certificate-based authentication can be configured using certificate map policy. Okay, now certificate map policy basically allows you to match certificate parameters like peer name or IP address or something like that. Okay, but it also depends on what kind of certificate did you download and install, or how did you install the certificate? Like, was the certificate installed based on the name of the device, or was it installed based on the IP address? So depending upon the parameters that are there on the certificate, you can put up some additional matching parameters so that you can have that much level of security when it comes to authentication. And then you define certificate to connection profile map. This is like an optional method, but it always helps so that you can have different parameters set for different types of tunnels that you're creating, especially at the HQ side. For different branches, you can have different matching parameters. So we'll go over all of this, but basically it seems like looking at the time right now, it seems like we'll go over the configuration parameters today, and then tomorrow we can start off with the lab portion of things, or we can focus on the lab environment and work on that more. Okay.
Sounds good.
Okay. So let's proceed. Go ahead then. Okay. So as you can see in this example here, okay, what we have out here is we have these two peers, and both of these peers are running remote networks of 10.0.100.0 and 10.0.1.0, and they have their own IP addresses out here, like 192.168.1.1 and maybe 192.168.1.2, okay, which is not mentioned out here, but assuming that could be the case. But both of these devices already have a CA certificate and an identity certificate, which they have received from the CA server. Okay, so that is one portion that is not mentioned in the slide, but we'll definitely go over that in our lab environment tomorrow. Okay. So there you go. I mean, let me quickly go over the options that we need to configure. So as far as configuration of VPN parameters are concerned, they are not going to change at all. The only thing that's going to really change is the authentication aspect, which I'll talk about a few slides ahead. But as you could see, just like in the previous example, you have to enable IKEv1 or IKEv2, and then you have to define the peer IP address or the connection name, like that is what you need to define, the interface on which you want to enable that particular profile, and then you define the IPsec, and the protected network is what you'll configure out here. Fine. The next most important thing is, there you go. This is the slide talking about the protected network or the interesting traffic, okay, which is again similar to what we had earlier. But now saying that, this is where things are going to change, under the IKEv1 or the IKEv2 settings. Instead of configuring a pre-shared key, you would go ahead and use the device certificate. And that's where you need to make sure that the appropriate certificate has been installed on the device. Okay, so from the drop-down, you would be actually able to see the appropriate certificate that has been installed. But even before you go ahead and choose that certificate, you need to make sure that there is a policy, which makes use of the authentication method as RSA-SIG, which is nothing but RSA signature. And that's where I need to mention one more aspect. Whenever we make use of PKI authentication, we are using an algorithm called as Rivest-Shamir-Edelman, that is RSA algorithm. So the PKI typically works on RSA infrastructure, and that's why it talks about authentication using RSA signatures. So this RSA-sig refers to RSA signatures, which are nothing but digital certificates. So that's one of the things that you need to configure when it comes to policy. So as you could see, there are already some default policies which are making use of RSA signature, but you need to make sure that those policies are there in place. And after you've done that, you can go ahead and use the certificate out here. Okay. So let me just go ahead and show that to you. There you go. Okay. So in this case, for IKE version 2, since there is no option of defining the authentication method, there's nothing much you need to do out here for IKE version 2. Okay. But for IKE version 1, you need to make sure that the authentication method is RSA signature. So there you go. After you've done that, you have to go into the device certificate section. Under the drop-down, you would see your identity certificate, and you need to go ahead and choose that. And this is what I was mentioning with regards to the parameters on that certificate. As you can see here, the CA server from where they have installed the certificate is external CA. That's like kind of a profile that they created for identifying the CA server. But under that, for the name of the device, they defined it as CN equal to ASA, hostname equal to asa.domain.com, CN equal to something else. That's the issuer name maybe. But all of these parameters I'll talk about more when we get to that certificate option tomorrow when we start working on the lab. But yeah, after installing it, that is the information that is going to show you out here. So that's the correct certificate that you need to choose. Once you've done that, for IKE version 2 also, you'll do a similar thing. But like I told you, for IKE version 2, just installing or selecting the certificate will not do. You'll also have to make use of remote peer certificate authentication allowed so that it enables the certificate-based authentication. That's what you need to make sure about. After you've done that, okay, nothing else like the IPsec proposal and the transform set. That is what you would do with regards to IKE version 1 and IKE version 2. So that's what they are showing up out here, just like what we talked about earlier. Nothing different out here. But yeah, the next most important thing is you also need to go ahead and configure the crypto map. But when it comes to crypto map out here, it's not going to be based on pre-shared key. Instead, it's going to make use of certificate. Okay. And when it comes to certificate, there you go. You need to make sure that the appropriate certificate is listed out here. Okay. You can also define keep alive and stuff like that. But this is another important aspect when it comes to configuring certificate settings on the ASA firewall. You need to make sure that the IKE peer ID validation is set to required. If the peer ID validation is not set to required, it's not going to look up into the certificate parameters and do the authentication. I mean, like I was mentioning earlier, you have the choice of looking up into the certificate contents for specific parameter values and matching it against the peer certificate. So it will not do that if it is not set to required. I mean, if you set the IKE peer ID validation to disabled, let's say, in that case, it's not going to look up into the certificate parameters at all. The only thing that it will look out for is whether there is a certificate. That's about it. If there is a certificate, go ahead and authenticate. If there is no certificate, well, it will fail. That's the basic way of doing it. But if you want to do proper authentication, you need to make sure that this setting is set to required. Okay. So that's where it also becomes important that when you're installing the certificate on the device, the parameters have to be set right, like parameters like peer ID or IP address or host name or those kind of options have to be defined correctly, which I'll discuss more when we get to that option of installing the certificate. And as you could see here, you also need to define the policies for the certificate to connection profile map, wherein you have to make sure that this option is checked. Use the configured rules to match the certificate to a connection profile. Now, this is the option which will make sure that certain parameters in the certificate will be matched against the peer certificate that has been received, and accordingly it will carry out or perform the authentication. But if this option is not checked, it will never go ahead and check those parameters at all. Okay, so there are two parameter options that you need to make sure that it is selected. One is this option here, and the other one which we saw in the previous case, IKE peer ID validation, which need to be set to required. Okay, and then you go ahead and configure something called as a certificate map. So this screen which you see out here is called as a certificate map, wherein what they're doing is they're defining a new map by the name of custom map, and then they're defining priority value of 10 to that, and they're mapping it to the connection profile or the tunnel group value of 192.168.1.1, so that they can add more mapping criteria, and that's what they're going to add next. Like, this is just a certificate to connection profile map, but after that they have to define the mapping criteria out here. Okay. So as you can see here, you can define subject, component like organizational unit equals, and in this case they are matching it to training. So similarly, you can define additional parameters like specific parameters which you want to match. Only if those parameters are matching within the certificate will the authentication be considered to be successful. If those parameters are not matching, the authentication will be termed as failed. Okay, so that's the additional criteria that you can define, which will make things more secure.
Right.
Going forward, there you go. That's the command line equivalent. So as you could see, the only additional thing that you would find is the tunnel group map, which you see out here by the name of custom map with the IP address of the tunnel group, and then tunnel group map enable rules, and under that tunnel group map default L2L group, and that's what they are configuring here. And under that, there you go, crypto CA certificate map, this one. Okay, this is where they are defining subject name attribute OU equal to training, which is nothing but the corresponding equivalent of the GUI option that we saw in the previous slide. Okay. So rest things would be similar, but as you could see here, the IKE version 2 local and remote authentication is based on certificate now. It's no longer based upon the pre-shared key. Another important thing is there is a trust point that you need to configure, which is nothing but the CA server identity, which we'll again talk about when we get to the CLI config when we start working on the lab tomorrow. Okay, I think everything else would be similar to what we looked at earlier, so I'll just quickly go on into the next one. And as you could see, the same set of ping, show, and debug commands would be useful, but just because we are using certificates, you have that additional command of show crypto CA certificates and show clock. These two become absolutely important, okay, because of the certificate, because certificate is based on the time, right? So naturally, the clock settings on the device should be good. And also, there's a show crypto CA CRL, that is certificate revocation list, which gives you a list of all the certificates that have been blocked or denied. So you need to make sure that your certificate is not blocked, because once it is blocked, it will be published on the CRL. So that's another thing that you need to be verifying. Okay, so these are some additional show commands which come up, but everything else would be similar. But let's take a look at the output of the show commands so that we know how it looks like differently. Okay. So these are the same debug and clear commands which we saw even in the previous case for pre-shared key. So that was this section, but let's see if I can show you the output for that. No, unfortunately, I do not have the output for the CA related commands, but I think I'll show you those outputs tomorrow. Okay. Okay, so that was it with regards to the theory that I wanted to cover. So do you have any questions on whatever we covered until now? I mean, with regards to the theory?
Yeah, that was great. That was really good.
Okay. So do you want to start with the lab portion right now, or do you want to continue tomorrow? I mean, because it's 9:45, I think already.
Yeah, right.
So I think what we'll do is, I think 15 minutes, I'm not sure whether I'll be able to cover much. So might as well we'll start off tomorrow, yeah?
Yeah, that makes sense.
Okay. So I mean, tomorrow I'll show you the Windows 2008 server first. We'll go over the CA server config, how I did it, or how did we set it up, and then we'll continue forward. Okay.
And so, Franklin, did you see my message?